Okay, in this section 12.5, we will be talking about equations of lines and planes. And as far as I see so far, this is the section most of the students are having troubles. You need to do enough practice to be able to understand and write these equations and planes nicely. So let's start, and about the practice part we can talk about during our online class. You know more. So to be able to write an equation of a line in the 3D space, what you need is you need a point and the direction of the line. Okay, you need one point that is given. Let's say x0, y0, z0 is given, and the direction of the line, this v, is parallel to that line. We are trying to write the equation of this line L. Okay, and what we know is this point x0, y0, z0, and the direction of the line. Once you know the point and the direction of the line, you can write the equation of a line in 3D space. So how do we do that? This is the equation. This is the vector equation of a line. R0 is the given point. You know, from origin to the R0, you can write this vector as easily by x0, y0, z0 with this a triangular parentheses. And v, where was that? There you go. And v is the direction vector, and t is just the parameter. So you can write the vector equation of line in that way. And since r0 is given with x0, y0, z0, and v is given with abc, let's say, you can write the parametric equation. So r is x, y, z. Instead of r, I write x, y, z equals r0, x0, y0, z0, t times v. V is ABC, so AT, BT, CT is coming from TV. And once you add with the R0, this is what you will get. If two vectors are equal, their corresponding components should be equal to each other. And from there, we can say that x equals x0 plus AT, y equals y0 plus bt, z equals z0 plus ct, right? This is the parametric equation of a line. We can write this metric equation. We will be doing it a little bit later. So in that one, remember that x0, y0, z0 is the given point. A, B, C are the vector that is showing the direction of the line, its components. Okay? Once you have that, you can easily write the equation of a line. Let's do it an example. You will understand it better. Find the vector equation. R equals R0 plus TV. Don't forget that. And parametric equation. X equals X0 plus AT. Y equals Y0 plus BT. Z equals Z0 plus CT, right? For the line that passes through the point. Point is given. This is R0, which is X0, Y0, Z0, right? And is parallel to the vector. If it is parallel, then their direction should be same. Then our ABC is 1, 4, minus 2. And as the next question, find two other points on the line. But firstly, let's write the equation of this line. Here R0, 5, 1, 3, 5ij, 3k, you can write it in that way. And the vector v, the given vector I, 4j minus k. Then the vector equation r equals r0 here plus t times v. If you complete the I terms together, j terms together, k terms together, you can see either the vector equation of a line that passes through this point and direction is that vector. Okay? And to be able to write the parametric equation, this is your x term, this is your y term, this is your z term. It's easy. So what you need to do is x equals 5 plus t, y equals 1 plus 4t, z equals 3 minus 2t. Remember that x equals x0, 5, plus t times a, 1 times t. Y equals b0, here 1, plus 4t. Okay? So in that way, you can write the parametric equations, or you can write the vector equation and directly call the components x, y, z from there. You can do it both. And for the B part, find two other points. So one point is given 5, 1, 3. Other than 5, 1, 3, this is the equation of the line, and t is a parameter. Just give different values for t and find two other points. Give t 1, you will get 6, 5, 1, right? This is another point when t is 1. Plugged in t equals -1, you will find 4, -3, 5. This is another point on this line. Give different values for t, you can find different points on this line. Okay. This is just one simple example for the equations of the lines, but make sure that you understand it well. We will be talking about equation of a plane later. Don't get confused. So for the line, you need the point and the direction of the line. But of course, these quantities are not given in general directly to you. Most of the time, you need to just try to imagine what you have, and from the tools you have, you need to get the things you need, which means that a point and the direction of the line. Okay, and neither the vector equation or parametric equation of a line or a plane, these are not unique. It will change according to the given point or the direction of the vector. It's not unique. Okay. Yes, another way to describe a line is the symmetric equation I was telling you. So you have a parameter. If you get rid of this parameter, you can get the symmetric equation of this line. For example, t is x minus 5, t is y minus 1 over 4, t is 3 minus z over 2. And since they are all equals to t, they have to be equal to each other. And from there, you can get the symmetric equation of a line. Okay, so what you need to do is just eliminate t from here. Sorry, x minus x0 over a, y minus y0 over b, z minus z0 over c is gonna directly give you the symmetric equation in here. Okay, if a is 0, you can easily say that when x equals x0, you will still need another equality for that, so you can get a symmetric equation in that way. And this is an example. For example, as I was telling you, sometimes not all of the equation of the point on the line or the direction of the line maybe sometimes is not given to you directly, but you need to find from what you have. So find the parametric equations and symmetric equations for the line through the origin and the point. Right now, what is it given to you? You have 2 points on the line. So you know that this line is passing through the origin and this point. So you have the point, that's good, but you need the direction of the line. Direction is not given, instead 2 points are given. But if this line is passing through the 2 points, you can easily find that direction. One of the point is origin, which is 0, 0, 0. Another one is 1, 2, 3. So the direction of the line will be from origin to A, OA. You know how to define a vector from origin to the given point A, which will be 1 minus 0, 2 minus 0, 3 minus 0. Here you go. This is the direction of your line. And since this line is passing through the origin, take the point x0, y0, z0, 0, 0, 0. A, B, C is 1, 2, 3. If you do that, you can write the parametric equation x equals x0, which is 0, I get the origin, plus at, a is 1, 1 times t, t. Y, 0, 0, 2 times t, z, 0, 0, 3 times t. This is the parametric equation. And if you solve these equations for t, you can get the symmetric equation, which is x equals y over 2 equals z over 3. This is the symmetric equation of this line. Okay? So this, make sure that please you understand that. If you will not, ask me during our office hours. And this is the line segment equation. Since we are talking about the lines, I am giving to you right now, but we will be talking about this in more detail once we are talking about the line integrals. Right now, to be able to write the equation of a line segment from R0 to R1, you can write it 1 minus TR0 times TR1. In here, T is going to be always between 0 and 1. Don't forget that, okay? This is important, as I told you, not right now, but once we are talking with the line integrals, you will need that. And this is another question. In here, the two line equations are given. As you can see, this is our first line equation. It's given in parametric form. x equals x0 plus at, y equals y0 plus bt, z equals z0 plus ct. So it fits the form of the line equation. The point for this first line is, this first line I can say that is passing through 1, minus 2, 4, and the direction vector will be 1, 3, minus 1. So just by looking at the equation of a line, I can say how this line is behaving. And for that one, you can easily say that this line is passing through 0, 3, minus 3. Direction is 2, 1, 4, right? And let's look at the example. We need to show that these lines are skew lines. So what is skew lines? Skew lines are the lines that they are not intersecting and they are not parallel, which means that they are not lying in the same place. Remember the coplanar vectors, just opposite of that. Coplanar vectors, they have to stay on the same plane, but in that one they should not stay in the same plane. Okay, these two lines should be not parallel, also should not be intersect. So to check the parallelity, it is easy. So what you need to do is check the directions. If the direction vectors are multiple of each other, then they are parallel. If not, they are not parallel. So the direction of the first one is 1, 3, minus 1. Another one is 2, 1, 4. 1, 3, minus 1 and 2, 1, 4 are not parallel because they are not proportional. Which means that once you multiply the first vector, you cannot get the second one. Since the second vector's first component is 2, once you multiply this one by 2, it will be 2, 6, minus 2. But this is not 2, 6, minus 2, which means that they are not factor of each other, which means that they are not parallel, okay? So checking parallelity is easy, but how can we check if they intersect or not? To do that, we need to solve them together. You know that intersection point is easy to find. For that one, since they are both equal to x, 1 plus t equals 2s. For the second one, since they are both equal to y, we are trying to solve them together. Minus 2 plus 3t equals 3 plus s. So, two unknowns, two equations. Just from these two equations, we can easily solve t and s. Once we do that, you can see that t is 11 over 5, s is 8 over 5. Just eliminate one of the parameter. And once t is 11 over 5 and s is 8 over 5, check the third equation if it is true. Once you plugged in that, no, it's not true. They are not going to be equal to each other, which means that they don't intersect. So, since they are not parallel and they don't intersect, we can say that these are skew lines. Okay? After that, we will be talking about the planes, but make sure that you understand the equation of a line so far.